Xournal HTR in 90 seconds. Installation cross-platform. Execute the following commands. Create an environment. Conda create -name like 3.10.11. Use this environment. Use this environment. Conda activate pipelines package using its installation guide. Install all dependencies of this package. Pip install -r requirements.txt. Install the package in development mode with pip install -e. Do not forget the ... Move plugins to folder content to Xournal config path /plugins Xournal pcore htr/ with Xournal config path being the configuration path of Xournal++. See Xournal Plus manual here. Linux run bash install linux.sh from repository root directory. This script also installs the plugin as explained in point 5 of the cross-platform installation procedure. The installation of the plugin is performed with plugins copy to plugin folder.sh, which can also be invoked independently of install linux.sh for updating the plugin installation. After installation, confirm that the installation worked by running make tests installation from repository root directory. Project description. Taking handwritten notes digitally comes with many benefits, but lacks searchability of your notes. Hence, there is a need to make your handwritten notes searchable. This can be achieved with handwritten text recognition, HTR, which is the process of assigning searchable text to written strokes. While many commercial note-taking apps feature great HTR systems to make your notes searchable, and there are a number of existing open-source implementations of various algorithms, there is no HTR feature available in an open-source note-taking application that is privacy-aware and processes your data locally. The purpose of the Xournal++ HTR project is to change that. Xournal++ HTR strives to bring open-source on-device handwriting recognition to Xournal+, as it is one of the most adopted open-source note-taking apps, and thereby HTR can be delivered to the largest possible amount of users. Project design. The design of Xournal++ HTR tries to bridge the gap between both delivering a production-ready product and allowing contributors to experiment with new algorithms. The project design involves a Lua plugin and a Python backend. See the following figure. First, the production-ready product is delivered by means of an Xournal++ plugin. The plugin is fully integrated in Xournal++ and calls a Python backend that performs the actual transcription. The Python backend allows selection of various recognition models and is thereby fully extendable with new models. Design of Xournal HTR. Developing a usable HTR systems requires experimentation. The project structure is set up to accommodate this need. Note that ideas on improved project structures are appreciated. The experimentation is carried out in terms of concepts. Each concept explores a different approach to HTR and possibly improves over previous concepts, but not necessarily to allow for freedom in risky experiments. Concept 1 is already implemented and uses a computer vision approach that is explained below. Future concepts might explore retrain computer vision models from Concept 1 using native data representation of Xournal++. Use sequence-to-sequence models to take advantage of native data representation of Xournal++. Use data augmentation to increase effective size of training data. Use of language models to correct for spelling mistakes. Concept 1. This concept uses computer vision-based algorithms to first detect words on a page and then to read those words. The following shows a video demo on YouTube using real-life handwriting data from a Xournal file. Despite not being perfect, the main takeaway is that the performance is surprisingly good given that the underlying algorithm has not been optimized for Xournal+ data at all. The performance is sufficiently good to be useful for the Xournal++ user base. Feel free to play around with the demo yourself using this code after installing this PAR.